Hello. So today we continue on chapter 15. Okay. In particular, we will concentrate on Coulomb's law, try to review it together and solve a couple of exercises so as we stress how to use it. So revision on Coulomb's law. One thing we agreed on yesterday is if we have two charges of equal charge, that is both are positive or both are negative, then they will exert a force on each other, which is a repelling force. So over here, Q1 is repelling Q2 by this force F12, and Q2 is repelling Q1 by this force F21. However, if the two charges are of opposite charge, then they attract each other. So here, Q1 is attracting Q2 by F12, and Q2 is attracting Q1 by F21. Okay, this is the direction of the force. Remember, a force is a vector quantity. It has direction and it has magnitude. So this is regarding the direction. Now, how much is the magnitude of the force? F12 is equal to F21. These two forces are exactly the same, and it is equal to K. It's a constant, which is 9 times 10 power 9. Absolute value of a Q1, so whether it's negative or positive, I don't care, I put it in absolute value, times the charge of a Q2 divided by the distance between these two charges squared. So one way to think about it, if I increase this charge Q1 or Q2, the force would increase, okay? So the force is directly proportional to this charge Q1 or Q2. Q1 increase, then the force increase. Now, if these two charges are brought closer to each other, that is, if R decrease, then this force also increase, because now these two charges are much closer to each other, so they would attract or repel each other more. Okay, so these are two concepts from yesterday. Let's see why start. Okay. So let's do this simple exercise by just drawing. So just drawing the direction of the force. 4-point charges Q1, Q2, Q3, Q4 are arranged as per the figure below. Draw the force F12, so let's do it in blue. Draw the force F12 exerted by Q1 on Q2. So it is by Q1 on Q2. So I come on Q2 and I draw this force. This is F12. Okay, and we put the arrow for the force. Okay, draw the force F13 exerted by Q1 on Q3. So we want force F13 exerted by Q1 on Q3. Q1 is positive, Q3 is negative, so they attract each other. So Q1 on Q3 is an attractive force, okay? It's an attractive force. This is F1 on 3. Again, we put the sign for that. Draw the force F24 exerted by Q2 on Q4. So Q2 is positive, Q4 is positive. So the force will be repelling. So it's by Q2 on Q4. So I will draw it on Q4. It will be in this direction. So this is F24. Okay. Finally, draw the force F3 on 1 exerted by Q3 on Q1. So Q3 is negative, Q1 is positive, so it will attract it. So it will attract it by the force F3(1). Okay, which is in this direction. So as easy as this, we just have to see if the both charges have similar charge, they will repel. If they are opposite charge, they will attract. And then if by Q1 on Q2, so we have to see which on which one, okay? So this is the solution. Let's do one exercise from your book. So the three positive point charges, Q1, Q2, and Q3. Q1 is 3 nanocoulomb, Q2 is 6 nanocoulomb, Q3 is 2 nanocoulomb. So just want you to see that nano, N is nano, is 10 power minus 9. Okay, so 3 nanocoulomb, this means 3 times 10 power minus 9. Okay, 6 nanocoulomb is 6 times 10 power minus 9. Q3 is 2 times 10 power minus 9. Okay, find the components of the force F12 exerted by Q1 on Q2. Okay, so I want the components of the force F12 exerted by Q1 on Q2. The first thing I do is that I draw this force. So I want Q1 on Q2. So I have Q1, I have Q2. Okay, and we will start by drawing F12, which is exerted by Q1 on Q2. So this is positive and this is positive. It means it will repel it. So the force will be a repelling force downward. Okay. This is F12. Okay, this is a Q1 here. This is a Q2. Okay. Find the components of the force F32 exerted by Q3 on Q2. So I have to add Q3 down here. Down here. Okay, so this is Q3. It's also positive. So this is positive, this is positive. So what does Q3 do to Q2? It also repels it. So it repels it by F32. So this is force F32. Okay. Now we need to find the components. So this was just the drawing. Now we need to find the components. So what is the component for F12? F12 is equal to this formula, K absolute value of Q1 times absolute value of Q2 divided by the distance between them square. Let's plug numbers. This is equal. K is 9 e to the 9 times Q1 is positive, so I don't have to worry about the absolute value. 3 nanocoulombs, so 3 minus 9 times Q2 is 6 minus 9 divided by the distance between them square, which is 1 square. Here is the distance between Q1 and Q2. In numbers, this will give me 1.62 times 10 power minus 7 Newton downward. Okay, so this is the components of vector F12. I can either say it is 1.62 times 10 power minus 7 Newton downward, or just draw it and say the magnitude of it is 1.62 times 10 power minus 7. Okay, so this is part A. Then part B, I have to get the components of F32. So F32 similarly is K Q3 times Q2 divided by R square. This is equal 9e to the 9 times Q3, which is 2e to the minus 9 times Q2, which is 6e to the minus 9 divided by the distance between them is 1 square, and this gives me the answer 1.08 e to the minus 7 upward. Okay. Finally, part C, find the magnitude and the direction of the resultant electric force acting on Q2. So I have 1.62 upward and 1.08 downward. So F resultant will be what? F resultant will be F32 minus F12, because F32 is bigger. And this will be 0.54 e to the minus 7 up. Okay. Because I have F32, 1.62 e minus 7. The F12 is 1.08 e to the minus 7. So the upward more than the downward. So I just F32 minus F12. And this will give me the resultant force. Sorry, this is downward because the downward is more than the upward. F12 is bigger than F3. Okay, just like this. Let's do another exercise, which is similar. This is the solution. Two charges, Q1 and Q1 equal 5.7 microcoulomb is on the x-axis. So let's write it here. I have Q1 is equal to 5.7 microcoulomb. Micro is e to the minus 6. Okay. Is on the x-axis at x equal minus 3. So let's draw the x-axis. This is the x-axis. Okay. Let's put 0 here. At x minus 3, so there will be 1 minus 1, minus 2, minus 3. So let's put our Q1. Okay. And the Q2 equal minus 2 microcoulomb. So we have Q2 minus 2 microcoulomb, so minus 2 e to the minus 6 coulomb, is on the x-axis at x equal plus 1. So at x equal plus 1. Okay, this is 0 here. So this is Q2. Okay. Determine the net electric force, magnitude, and direction on a third charge Q3. So I have Q3 equal minus 3 microcoulomb. So minus 3 to the minus 6 coulomb placed at the origin. So Q3 is here. Okay, it's placed at the origin. So similar to the previous exercise, I have to get Q1 on Q3, Q2 on Q3, and then we see how to get the resultant. Okay, so let's look at this. So Q1 is positive and the Q3 is negative. So how is Q1 on Q3? Q1 on Q3 is attractive because this is positive, this is negative. So it's an attractive force. Let's do it in not different colors. So this is Q1 on Q3. The force Q1 does on Q3. So this is F13. Okay. Then I want Q2 on Q3. Q2 is negative, Q3 is negative, so it's a repelling force. So Q2 is repelling the Q3. So it's also in this direction because it's repelling it. So this is F23. Okay. Then we get the magnitude of each of them. So F13 is equal K, which is 9 to the power 9. Times Q1, which is 5.7 e to the minus 6, times the absolute value of Q2, which is 2 e to the minus 6, divided by the distance between Q1 and Q3. How much is the distance between the Q1 and the Q3? It's 3 meters. So this is the 3 square. F13 is equal to 0.0171 Newton. Then F2 on 3, it's equal to 9 to the 9 times Q2, which is absolute value of Q2, which is 2e to the minus 6, times absolute value of Q3, which is a 3 to the e minus 6, okay, divided by the distance square. What is the distance between the Q2 and the Q3? It is 1 meter, because Q2 is placed on 1 meter. So this is 1 square, and this will give me the answer to this is 0.054 Newton. Okay, now what is F net? Which one? F net will be, both of them are in the same direction, so I just have to add them up. So it is F13 plus F23. This is equal to 0.0171 plus 0.054, which is 7.11 e to the minus 2, or times 10 power minus 2 Newton. Direction, this is the magnitude. Direction to the left. Okay, so the resultant force is this F net. Okay, so this is it for today's lecture, and next week we give some more ideas. Bye bye.